Generally, when people talk about a thunderstorm as opposed to a hurricane or, I don't know, like a mid-latitude storm, for example, generally what they're referring to is that explosive release of energy that comes from the condensation, which drives a narrow updraft. So a thunderstorm cloud is produced, or it's associated with a strong updraft, so strong ascending air that is about 2 kilometers wide on average. It's actually an area of active research why it's about 2 kilometers. The current paradigm is that there's a balance between how sleek the updraft is. So if you imagine a swimmer swimming through the water, if they're really sort of sleek and thin and streamlined, or maybe an aeroplane flying through the air, if it's a really sort of well-designed aeroplane, it's really streamlined, it can sort of slip through the air smoothly. But if it's really big and bulky, it kind of is going to get stuck, or it's not going to be as fast. So it's the same principle. That is what gives the updraft a preference for being small. The problem is if it becomes too small, then the warm ascending air, the sort of explosive air, that ends up just getting mixed out. So the air is also sort of mixing as it's ascending. And so if it's too thin, it just gets mixed out to nothing. And so it's the tension between those two factors that produce these updrafts. It varies a bit around the world, but on average about 2 kilometers wide. So I'd say that's probably the key feature of a thunderstorm cloud, an individual thunderstorm cloud. There are other types of storms, you might say, like sometimes people describe a mid-latitude cyclone as a storm.